Hello everyone. Today we are going to discuss numerical solution of algebraic and transcendental equation. So we have in this chapter we have three methods. One is bisection method, second one is Newton-Raphson method, and third one is Regula-Falsi method. So today we will discuss Regula-Falsi method. So Regula-Falsi method. The Regula-Falsi method or false position method or method of false position is also sometimes referred to as the method of linear interpolation, and it is the oldest method for computing real roots of an equation fx equal to 0. To find a real root alpha of fx equal to 0, we first choose a sufficiently small interval x0, x1, this one, x0, x1, this interval x0, x1, in which the root alpha lies. So here is the root alpha lies. Then f0, f of x0 and f of x1 must be of opposite signs, so that f of x0 into f of x1 less than 0, and the graph of fx must cross the x-axis between x equal to x0 and x equal to x1. Since the interval x0, x1 is sufficiently small, the portion of the curve between a x0 f of x0 and b x1 f of x1 can be approximated by an secant line or straight line, and show that the intersection of the secant AB with the x-axis gives the approximate value x2, say, of the root. So the equation of the secant line AB is y minus f of x1 divided by f of x0 minus f of x1 equal to x minus x1 divided by x0 minus x1. So keep this one in left hand side, y minus f of x1, this one equal to f of x0 minus f of x1 will be in numerator. In denominator we have x0 minus x1 multiplied with x minus x1. So we are putting this one equation 1. Now in place of y we are putting y equal to 0 and x equal to x2. So here x equal to x2 and putting along the x-axis, so y equal to 0 in equation 1. So it will be, after deriving we get x2 equal to x1 minus f of x1 divided by f of x1 minus f of x0, x1 minus x0. So how do you get it? We are putting y equal to 0, f of x1. So minus of f of x1 equal to f of x0 minus of f of x1 divided by x0 minus x1 and x2 minus x1, because we are here we have written x equal to x2, so we are putting x equal to x2. Keeping this one in left hand side, x2 minus x1, so this portion x0 minus x1 will be in the left hand side, so this one we will write x0 minus x1 f of x1, here minus sign is there, and this one f into 1 by f of x0 minus f of x1. So after this minus sign it will be, so here we can write, so here just see that here we are taking one minus common, here we are taking one minus common, so after taking minus common it will be x1 minus x0, that one, and after minus common it will be f of x1 minus f of x0, that one, and this minus sign it will be plus sign, and minus sign will be there, this one, and we are shifting minus x1 in right hand side, so you will get this equation. Next is we have to find out f of x2. So we have two options, either it is equal to 0 or it is equal to not equal to 0. So if it is equal to 0, we can say x2 is real number of f of x0 equal to 0. Otherwise x2 either f of x0 to x2 less than 0, or f of x1 f of x2 less than 0. That means, so after getting this x2, we have to find out f of x2. So if it is, if f of x2 equal to 0, that means this one is a root. X2 is a root. X2 is a root at the of fx equal to 0. If this is not equal to 0, so here, so root lies between either x0 to x2 or x2 to x1. This is your next assumption. So we are taking root lies between x0 to x2. Just see here, root lies between x0 to x2. So here interval is x0 to x2, this one. Otherwise x1 to x2, but we have taken this one. So for convenience, here we are rename the interval. Rename means here we are renaming x0 to x1. Here we are renaming x0 to x1. So your new interval is x1, x2. Just see, we are renaming the point x0 as x1. So our new interval x1 to x2. So x1 to x2. So that means here again same thing, x1 to x2. So for x1 point we are having positive value, for x2 we are having negative value. So root lies between f of x1 into f of x2 must be less than 0. So root lies between the interval. That means we are naming the interval, that is x3. X3 is the approximation. So again for x3 we are having another second line. So that is the, according to the formula, the formula is x3 equal to x2 minus f of x2, f of x2 minus f of x1 into x2 minus x1. So how do you get the equation? Same thing, same formula we have written here, the x1 and x2, the new interval. So like this way we are having this formula. So this is for the next approximation, where the root of the approximation is x3. So same way, proceeding in this way, we will get the general formula based on the above process, which is xn plus 1 equal to xn minus f of xn divided by f of xn minus of f of xn minus 1, xn minus xn minus 1, where n equal to 1 to 3. So that means, so same way we are having x3. Again we are renaming the interval. Again for this point we will get positive value, for this point we will get negative value. Again the middle next approximation x4, but this is not the real root, because again we are having positive value, negative value. So in this way each and every time we are facing false position. So that's why the name of the method is Regula Falsi method, or method of false position. And this process is repeated until the root is obtained to required degree of accuracy. Okay. So this way, this is the derivation of Regula Falsi method. Now the convergence of Regula Falsi method here is, just see that Regula Falsi method is order of 1.618. This is the convergence, order of convergence, which is very, very important. No need to prove, just remember the statement. Regular Falsi method order of convergence is 1.618. Next is advantage and disadvantages of regular Falsi method. So first is advantages. The method is simple and easy to implement. Number two, the method does not require to calculate the derivative of fx, which is difficult sometimes. So here what is the meaning of derivative? Actually in Newton-Raphson method, in formula we have derivative. So that's why regarding the Newton-Raphson method, in this method there is no need to find the derivative, because in our formula there is no requirement of derivative. So that's why here is the advantage of, if we compare with the Newton-Raphson method. So here is the advantage. No need to find out the derivative. Number three, the method is evidently convergent. And the disadvantages are, the convergence of method is very slow, and the method is not always suitable for practical computation. Next is one example regarding this. So find a real root of the equation x to the power x plus x minus 4 equal to 0 by regular Falsi method, correct up to 2 places of decimal. Two places of decimal. So just see that there is no interval is given. So that means you have to find out from yourself. So function is there, x to the power x plus x minus 1. So since here we are using regular falsi method to find out the smallest positive root, so always we will start from 0. So here if 0 is minus 4, that is less than 0, okay. So we have to find out another point of the interval where we will get the positive value. So let's find out. So we are putting 1. So 1, just see here again we are having minus value. So not. So this is not possible the interval. So we are going for 2. Next interval, next point. So next point is 2. Next point is 2. We are having the positive value. That means 0 point we are having negative value, for 2 point we are having positive value. So f of 1 into f of 2 less than 0. So just see here we have less than and here we have greater than. So f of 1 into f of 2 less than 0, that means then there exists at least one root in 1 comma 2. So according the formula, so where is the formula? Here is the formula. Xn plus 1 equal to xn minus f of xn divided by f of xn minus f of xn minus 1, xn minus xn minus 1. Okay. So here according to the formula what we need n means number of iteration, then means xn minus 1, f of xn minus 1, xn, f of xn, xn plus 1, f of xn plus 1. So these things we need to calculate the formula. So first of all, here it is minus. Now question is why you have written here minus and why here written here plus. Actually for since xn minus 1, so first tell me between xn minus 1 and xn which one is lower? Obviously this one xn minus 1 is lower. So this is the first point of the interval and this is the last point of the interval. So first point of the interval is 1. So for 1 point we are having negative value. So that's why here negative. For last value 2 we are having positive value. Just see plus 2. So that's why positive. So this will be changed according to the problem. Problem to problem it will be changed. Suppose another problem we are having for 1 value this is positive value. For 2 value we are having negative value. So here sign also changeable regarding this. So first iteration is, so here first point is 1. So we will put here 1. Last point is 2. We will put here 2. So for 1 point we are having minus 2. So that's why minus 2. For 2 point we are having positive value. So plus 2. Okay. Xn plus 1 means the formula. So we are putting all the things in our formula. You will get 1.5. Okay. So for 1.5 we are having this one. We are putting 1.5 here. So you will get according to the function, you will get the value that is 0 minus 0.663. So since it is minus, so that minus column will be changed. What is the change? Whatever the point of the root, this one will be your new point. So 1.5. Why? Because this is minus sign. If it will be positive, so that one will be changed. That one will be changed. But there is minus value. So 1.5 will be here. So for 1.5 we are having this value. For 2 no change. Again we are putting all the things in our formula of regular falsi method. You will find 1.624. So by putting 1.624 in this function you will get minus. Again we are having minus value minus 0.178. So for minus value again at the point of 1.5 it will be changed and change value is this one 1.624. Same way this process carry forward. Again we are having 1.6551. Again we are having negative value. So after third iteration what we have seen, we are just see that we are starting with here 1 comma 2, that is your interval, but after using the regular falsi method, so your interval is squeezing. That means from where we have started from 1, then 1.5, then 1.6 dot dot dot. So just see that here interval is reducing the interval. So in this way we will find the desired degree of accuracy where root lies. So okay, so now now question is up to how many iteration we will go. So that depend on the here correct up to 2 decimal places. So 2 decimal places means from where we will count from the decimal point. Just see in the second iteration we have 1.624. third iteration we are having 1.6551. So if you taking the difference, so you will find out 0.03 like this we are having. So when the difference is very minimum, we can stop our process. Okay, so since we are having again minus value, so again this will be put, we will put here again the same process applicable. So what we have 1.662. So just see the difference, again we have 0.01. So can we minimize? So that's why we are starting, we are having another iteration. So again here minus value, so this value will be changed, 1.655 will be 1.662. We are having this. So after using the same thing, we are having, so first tell me which one your answer column. This is your answer column. Actually we are going to find out smallest positive root. Okay, our question is smallest positive root. So this is your answer column and this is your verification column. So after finding this four things in our formula, we are having the root is 1.664. Now you can find out the difference. Just see that 1.664, 1.662. So difference is 0.002. So now we can finish here. That is actually what is our aim? Our aim is to find out the smallest positive root, and the difference is when the difference of previous root and the next root is very minimum, we can stop our process. Okay, so we can, since the difference is very minimum, so we can stop here. So that's why we have not done this this column. Okay, now the question is, if somebody will write another 6 iteration, can we have the same answer? Actually, in numerical method, your answer will be approximate, not exact answer. So if somebody will do the 6th iteration, so he or she will get same result, but 0.001 or 0.002 will be differ. So that is not the problem. You will get the full marks. So whenever the difference is minimum, you can stop. Okay, so here the C 0.002, so we can stop our process. So the required root is 1.66. Now the question is why 1.66? Just see that correct up to 2 decimal places. So 2 decimal places means, just see, 2 decimal places means you have to find out 3 decimal places. So 2 plus 1 is 3. So 1, 2, 3. Since third elements which is less than 5, so previous one no change, so that's why required root is 1.66. so this is your answer. Okay, next thing is another example, or also we will take, find the real root of the equation x plus log e base x minus 2. So same way, we don't have here interval. First we have to find out the interval. Just see, f of 1 is minus 1 showing, f of 2 is 0.693 showing. So here root is 1 and 2. So root is 1 comma 2, that is 0 less than 0. So root lies between 1 comma 2. So same way, for one value, for 1 we are having minus value, so here minus. For 2 we are having positive value, so here we are having just plus sign. So this way you will find out 1. For 1 we are having minus 1. For 2 we are having 0.693, this one. And just this is the root part, that is 1.596606. And here, and the verification column is so this is your positive one, so positive column will be changed, so here, and this one will be put here. Just see here, there is no change since this is positive one. So same way it is continuing, 1.5599, this one again positive value, so again this one will be changed here. There is no change, so we will get 1.5773. Now we can find out 1.5593 and 1.5573. So what is the difference? Difference is here 6, here 2, so 0.200026, which is very minimum, so we can stop here. So what is the question here? 2 decimal places, so last your answer is this one. So 2 decimal places means here we have to check up to 3 decimal places, so that is your 7. Okay, 7 means greater than 5, so your answer will be 1.56. so this one, your just you will cut the one, this one, because this is not the correct one. Your correct answer is 1.56. okay, so this is correct up to 2 decimal places. Okay, so in this way, we can easily solve the method of false position or regular falsi method. Okay, so dear student, we will discuss next class in another method. So till then, so bye bye all of you. Thank you all of you.